So in this spreadsheet, we have a formula. Here we have a graph. This is a graph of the formula. Z equals negative, in parentheses, x squared plus y squared, parentheses, plus 4. So it's not the most complicated formula in the world, but we'll just use it as an example to see how Solver's evolutionary method works. So first thing we need to do in cell B5, we need to create this formula. So it's going to be equals, we'll multiply -1 times x squared, I'll just say x times x, plus y squared, I'll do y times y, and then I'm going to add 4. Okay, so then I can pick a point on this plane. So what if x is 6 and y is 7? Okay, the value is going to be -81. And if I go bigger, it's going to get a lot smaller. But what's the maximum point? So I can guess and check here if I want to, or I can use Solver. So to use Solver, make sure you have the Solver add-in. You can go to File, click Options, Add-ins, Manage Excel Add-ins. Just make sure that Solver is checked. So I'm going to cancel out of that because I've already got it in there. So I'm going to open up Solver. So I want the max of Z. And I'm going to change the x and y values. Now, we don't need to make them non-negative because we could go up and down the number plane. So I'm going to leave that box unchecked. I'm going to use the evolutionary method, which is selected. So let's bound the search space just a little bit. So add a constraint so that these two values have to be less than or equal to 50. I'm going to click Add, and I'm going to select those cells again and make them greater than or equal to -50. Okay. And so this is good. So evolutionary is selected, so I'm going to click Solve, and let's see what happens. You can see Excel is going through a bunch of different options, so it found a solution of +4. So it's trying to see if it can beat that value of +4 right now. This can run for a little while because Excel's trying a lot of different numbers here. Because I did not constrain the x and y to be integers, it's trying, decimal places. So 1.1, 1.0001. There's a lot of different numbers between -50 and 50 if you're including a lot of decimal places. So I'm going to pause the video right now while this finishes. Okay, it finished up and it found a solution. So I'm going to keep that solution. You can see Excel put a whole lot of decimal places in there. That's basically 0, 0. Excel was very precise. It did not try 0 and 0. If it tried 0, 0, that would be perfect. But the answer that it had in there, we're moving the decimal places 7 places to the right. So that was 0.0000000 488. So lots of zeros after the decimal places. So essentially 0. So it found a good solution for us. Let's just, for giggles, I'll set 5, as my starting point. And I'm going to go to Solver. And let's just, what if we changed our method to simplex LP and click Solve? Well, it tells us that the linearity conditions required by this LP solver are not satisfied. So it's not even an option for us. I'll open up Solver again. Let's choose GRG nonlinear and see if that works for us. Click Solve. And this actually works very well. It's actually much faster in this case than the evolutionary algorithm. This case is actually a very good use case for the GRG nonlinear method. So I'm going to keep this solution. So in this case, the evolutionary method worked, the GRG nonlinear worked, but the simplex LP would not even run. So it's good to know which options you have available to you and to be able to set up the constraints and everything so that you can switch back and forth between the methods to see what gives you the best performance and the best results.